I was browsing a seller on eBay's listing, and they sell mainly technical stuff. Their name is CGL3478, and it's all sort of industrial components, quite interesting stuff. And one of the things they had was this sort of surge suppressor, and it's designed to go into a distribution board. I mean, in Europe, we typically have distribution boards that take DIN rail mounting components. And it's got the live and neutral in, and then it's got an earth connection at the bottom. And if you look at the bottom, there's a sort of bus bar, a couple of screws, and a little bus bar slotted in the side that links them together. And I'm guessing that these blocks, which do unplug with a bit of effort, these, I'm guessing, are metal oxide varistor blocks. And I look at these and think there's a little green pip out the bottom that aligns up with that. I'm not sure what that's for. And then there's a little flag in the window here. So I wonder if it's got a way to detect if it's, you know, gone open circuit, gone, you know, if it's stopped being effective. And one of the things about these surge protectors, if they are metal oxide varistors, I'm guessing, then when they fail, they start getting hot. So I wonder how they're actually going to deal with that without the whole thing just bursting into flames. I wonder if it has a means to detect that and disconnect it. So let's open one up and take a look inside. Because I see it's got a panel that can presumably be prized out. Magic spudger gets in. Oh, I can hear a spring inside. That's a bit daunting. Is this going to unleash its guts with a bang? Ew. Oh, okay. What have we got? I'll just nudge up just a tiny bit here. Not too much though. We've got this blade coming in here onto a piece of braid, and then on this contact going down to what looks like a solder joint here, that if that solder melts, if this gets hot, that fusible link, soldering iron's on. Let's test that, shall we? Let's wet the iron with some solder. Give it a wet it with some solder and see if this fusible link works. So it's going to ping solder everywhere. I wonder what temperature. Oh, there, it's gone. I have to say it's pinged, but it's kind of, it didn't go up very high. I thought it would have gone higher than that. It didn't seem to actually pull that very clear. In fact, the solder, maybe it's just the fact I had the solder iron on that, it left a bridge. That's a bit disconcerting. So what if I lift that out now? And this. So the two connections, this one's going to, well, this one's actually feed in, the other one's going to ground. I suppose ultimately if it was getting hot, that solder would, if it had formed a slight bridge, I'm just trying to make excuses for it now, haven't I? Anyway, what's the inside here is the bit. I'm guessing it's going to be just a large round metal oxide varistor, but the only way to find out is to actually open it up. Let's get a pair of snips and start nibbling here. Well, let's just use brute force, in fact. No subtlety. Ow. Quite brittle, hard plastic. It must be designed for the high temperatures involved of things failing. So let's chop our way in here and see if I can actually just crack into this and see if it gives us a clue. That is tough. Very tough stuff skittering around the room here. Yeah, it's not very, I'm not very subtle about this, am I? I'm guessing the reason they pot it is just to actually, oh look, I really have just mashed the finger. That's going to hurt. Not to worry, it's not the first time I've done it by a long chalk. This is one of the perils of using brute force. The fingernail, yeah. The fingernail has been prized off slightly, and rather annoyingly. Its partner nail here, was it this one? Yes, it was. I recently jammed a bit of circuit board material up the end of it. That was just not nice. It's been quite unpleasant. That's what happens. Fortunately, all our hands have an auto repair function, so everything will just grow in again. Right, so I'm getting down to really just the piece of resin here that's been potted in here. Can I prise that out with a screwdriver without stabbing myself with a screwdriver? Stabbing yourself with a screwdriver is also a common thing. It's a special engineering skill. Right. Well, that's kind of intriguing. It's got these little things that bite into that. Oh, they might be... Oh, they're to space up the metal oxide varistor, I'm guessing. Let's... Yeah. Big disc metal oxide varistor. Just chew in a bit more. See if we can liberate any more truth from this. Oh, right, okay. Find the bit again that's just pinged off. Fundamentally, yes, it's a metal oxide varistor with the tab going right up to one side, and it's presumably, I wonder if it's bonded on in some way. And then presumably, this over here, well, let's find out. Let's nibble in a bit further. Yeah, it's got a metal tab. It had a metal tab. It's not got a metal tab anymore. That is going across to the other side of that disc. Yeah, this is getting to the point of finger damage, isn't it? I'm not revealing much more because it really is just that disc in there. Quite a tough disc. It's standing up to Clivey punishment quite well. There's the other tab. Can I separate that yet? Is it going to separate, or is it absolutely bonded onto the resin? I think it is kind of bonded onto the resin. I don't even know if the spudger would separate that. No, I think the resin's actually bonded quite tightly onto that. But that's more or less it by the look of it. It is fundamentally just a large metal oxide varistor inside there, potted in, with that fusible link that just is spring loaded, and when that springs up, what happens when that springs up? There's that wee hole out the bottom. Was it? Trying to remember how it was. I've kind of wrecked it now completely, haven't I? Yes, I have. Where was the window? No, I haven't a clue where the window was. So when that actually goes up, it looks like that little thing at the back. Instead of going out, it actually pops in. But I don't see any mechanism here. I wonder if it was some sort of... Oh, you know what? It might have been to actuate auxiliary contact that would normally get pushed down by this pin being there. And when the pin pops in, the contact then closes to signal to somewhere that the part of the protection has failed. That's quite interesting. I'm not giving up on this. I'm just going to keep chopping into bits. Oh! It does kind of reveal everything, doesn't it? There's not much more to reveal. That's really just it. It's a metal oxide varistor in here, the disc varistor, with a metal tab on that side and a metal tab on that side, and that's fundamentally it. So that's quite interesting. I'm kind of intrigued. I want to actually see if I can trip this one as well now, and see if it was just me bridging it with the solder iron that caused that, or if it's actually going to break in a controlled manner. So let's get violent with this one as well then. This time, I'll heat it from the bottom. Ooh, sexy. And I'll zoom in this a bit so you can actually see it click in operation. So let's zoom right up on this. Let's bring in something to actually make sure the focus goes onto that. So I'll just actually put the information here and just I'll just refocus onto that. That looks pretty good. Line it up, and this is the wee solder joint here that's going to heat up and fail. So let's get some solder on the solder iron and just put it on there. And that's the flag. That's the little pip that sticks out the back. So when this heats up, that still didn't break the circuit terribly well. It seemed to pull the solder up with it. It's broken the circuit, but it's also put that little wick up. But having said that, would that still be hot if it was would the solder... I guess if there was any arcing across, the solder would then just sort of like melt away from it. Yeah, not impressed at that, but there you go. A transient sort of transient suppressor, just a big metal oxide varistor across your main incoming supply with this semi kind of safety circuit-ish type thing. So quite interesting, well worth opening. You know, looking at this, when it didn't really break as much as I was expecting it to, and I was like, well, maybe, you know, I'm just not giving it a fair test. I think I gave it a fair test, and this little spring here is fully closed up now, and the little flag in the window is only partially way across, making me wonder, is there something wrong with the manufacturing of these? Is that the wrong spring? Is there, you know, the plastic not quite the right size? Is this metal the wrong size? Something is wrong that it's not guaranteed to break that circuit with the slight risk of the web of solder going up onto it. Maybe it's because I contaminated it with a different type of solder. I'm not sure. But I wouldn't actually trust that. It just doesn't seem right, as if it's just not quite assembled correctly or the components are just wrong. Also, when the plastic thing is so close up to the window that if it does go up higher, it starts making contact with the front of this, which sort of fills its movement. So I wouldn't trust that. That's a shame, because otherwise, you know, it's a reasonably sensible approach. It's a metal oxide varistor with the metallization on the side, and then the main terminal soldered on. And when it gets hot, theoretically, it melts the solder and it breaks the circuit. But in this case, there is a genuine risk that it wouldn't necessarily break the circuit. And I'm not sure what would happen with the sustained heat then. So that's not that impressive. It's a shame, because it seems quite a nice, robust, well-designed product right up to the point that doesn't seem to give much clearance. I'd rather it's sort of snapped apart from maybe about 3 or 4 millimeters over 1/8 of an inch to try and properly break the circuit in a decisive manner, but that doesn't happen.